Thanks, everyone. Glad you're here such a late hour. I know there's lots of activities going on tonight, so I appreciate it. We're here to talk about the Internet of Cars and car security in general. In particular, when Bo first asked me to do this talk, I started thinking about kind of what I wanted to say and what I wanted to talk about, and along with Abe and Kevin here. And I realized that the best way to really talk about it was that I'm more of the narrator in a sense. So I don't know how many of you have seen This American Life on NPR. And I'll see a couple of eyes. People fall asleep when I say NPR. But the reason I want to say that is I'm your host today. I'm Ira Glass. So I'm here to actually talk about a story in three parts. And so the first part is basically, if you know the format of This American Life, it's telling stories about interesting things. And so that's the point of this talk here. We're also going to have a lot of Q&A and questions. But really the three parts are kind of formatted around part one, which is just a background into automotive security, an update into latest research, policy, and more generally how to get involved. So if you're someone who's interested in vehicle security, we'll talk a lot about different ways you can get involved with that. But like any good story, it's more than just kind of the background and the history and what's been happening recently. It's also about the new things. So in particular, this is a pretty cool self-driving electric vehicle, which Abe will talk from his perspective at a car company that has a chance to build things from the ground up. So they don't have a lot of the history and I don't want to say baggage, but they don't have a lot of the kind of background that a lot of the other OEMs have to deal with. So he'll talk about challenges he sees in designing a new vehicle architecture, challenges in hiring, and just overall challenges he sees in the automotive industry, having worked there for many years. And then we're going to go back, and not as the past is bad, because I want to use the fireside chat as sort of the method introduced by my third speaker, Kevin Tierney from General Motors. So he is going to be here to provide a Q&A to everybody and to talk kind of about the history and in particular answer some questions we have about how GM is approaching vehicle security from their perspective. And so, like to say, General Motors has been here for 100 years. NIO's been here for how long? 6 or 4? Three. Two very different perspectives, but equally important and equally something we should talk about. So, as This American Life goes, this is part one, the Internet of Cars. What it is, what the industry is doing, and where we are going. I didn't bring my glasses to be IRF totally, but you guys can imagine that. A little background into myself. Who am I? So I'm a passionate security researcher. I guess I'm a policy wonk. I kind of have happened to get involved with a lot of policy stuff in the course of my past life, doing a lot of work with Carnegie Mellon Cert CC. And currently I'm a cyber defense manager at Rockwell Automation. I got involved in sort of the ICS space. But this talk is going to be more about cars itself. And a little personal factoid, I'm heavily involved with vulnerability disclosure research, and especially kind of as a focus in the cyber physical side. So I get really excited about CVSS scores. So again, I'm waiting for people in the back to just start leaving right now. So the Internet of Things, we talk a lot about that. But in particular, we need to think about it's more like the Internet of Cars and why that's important. So we know lots of stuff's connected to the Internet. Cisco tells us it's 2 billion connected things shipped in 2014. But what's interesting is a few kind of statistics I wanted to point out, just why this is important, even though I think a lot of you understand that. There's 250 million cars on the road in the US alone. 40 million of them are already connected to the Internet. 75% of new cars themselves will be shipped with Internet connectivity in 2020. That's not that far from now. 22% of all cars will be Internet connected by 2020. Of all vehicles on the road, that's a significant amount. Now, that picture on the right, what you're seeing there, is an interesting study that Accenture did. So they found out that when they interviewed 18,000 different individuals, just the public who about their car buying habits, they found out that what they want is technical features. And in fact, when they interviewed all these people, a large majority, almost 50%, said that they will consider the tech features in that vehicle over any other option. And if you look at what the tech features they desire, they're things like autopilot, lane keeping systems, night vision device, that sort of thing. Now, from a security perspective, you start wondering, these are things to be concerned about. We can't stop the cars from coming. They're going to come with these features because the public demands it. But we can be there to maybe help guide it into a secure and safe fashion. I want to also present a few dates here and why these dates are important. So in 2020, this is, and these numbers are kind of a little bit debated, but some automakers expect the first fully autonomous commercial vehicles. So that means full self-driving, no hands on the wheel type of thing. In 2021, the vehicle-to-vehicle, the vehicle-to-infrastructure rollout begins, assuming that the approval for the rulemaking gets through this year. And by 2023, full compliance is required. And then in 2025 is when some analysts expect, basically, that we will see all cars on the road, excuse me, not all cars, all automakers will have an autonomous model available. So, and the question I think you can expect the answer here is, with all this new connectivity, who is going to secure it? So a little history about myself. I also am a passionate medievalist and interested in kind of history. And there's a very interesting picture here that this is the Battle of Bouvines. Most people don't even know what this is. So this is a battle that was between the French and the English combined army with the Flemish and the Germans. Basically, the French won this battle. It was a huge rout. But what this ended up leading to is that the current king of England at the time, John, he was so badly beaten that when he came home, his nobles revolted. And this revolt is what became of a document most people know as the Magna Carta. So if you think about it from the sense of, one battle, not even very well known, that resulted in nobles revolting to cause action. I just want to be able to think about that from the cavalry perspective of, we fight many little small battles in policy circles amongst a lot of different standards bodies, but that's what can cause change to happen. To dive into some of the recent automotive security research. So I'm not going to go back to 2010 and talk about kind of the original kind of car research happened from University of Washington. I'm not going to talk about the 2014 GPAC, although that's important. Just this last year, what can we focus on? So what's interesting is that we have a couple different research that came out. So in particular, it was the gateway internals of Tesla Motors. That was done by the Tencent crew at Keen Lab, where they basically are able to fully control a Tesla and cause Tesla to change their firmware update model from where it was not being signed to being signed. And correct me if I'm wrong, that was. Secondly, the security analysis of in-vehicle infotainment system. So this is a pretty cool one that was done at Woot in 2016. They focused on, from an app perspective and an in-vehicle infotainment system, a lot of the automakers are moving towards standardized systems. So you plug your phone in, you get that nice mirror up there that shows your current phone, whether that's Android Auto or Apple CarPlay. This one in particular was very similar to that. So they found that basically the apps on both the IVI side and on the phone side both had significant security weaknesses. And I'll talk a little bit more about why that's interesting if you're interested in getting into vehicle security. Third, mobile apps and stealing a connected car. So some researchers did some work, I think it was at RSA, where they talked about how a lot of the apps out there for vehicle security, or excuse me, for vehicles in particular that you download and use with your car, are really poorly done or just done not in a secure fashion. And so they were able to do a lot of interesting things with the vehicle by basically attacking the app itself. Last one is basically an interesting privacy story. So Henderson was at RSA. He talked about a story where he had his car, he sold his car, and the app he had, he was unable to get the app itself to disassociate itself from the car. So even though he sold it to somebody and he tried to get the app, disconnected, he could still actually control the vehicle functions despite what the automaker was telling them. And it turned out that they never considered the model of someone selling their car and that app no longer having to be used. So it's kind of a weird situation. From a trending perspective, so I focus on four. There's a number of different ones, so those are kind of the main ones. There's an increase in use of mobile applications. So obviously, we go back to that picture I showed you of what the demand is. Consumers want connectivity. They want to be able to turn on their heated seats from the comfort of their home. What's that resulting into is an extension of that trust boundary in the vehicle to that mobile application. So now we have to consider not just how the vehicle is designed, but all of that kind of ecosystem out to the application, to the servers, to the in-vehicle systems. Secondly, data privacy. So everything's stored on the app, it's stored in the car, it's stored in the cloud, it's stored wherever. That's also privacy issues. We have GPS locations, we have very personal information about individuals that are stored everywhere. Still an issue with OEMs. Lastly, not much public research. So we haven't seen to reference the GPAC, we haven't seen another GPAC. And I started thinking about why and talking with Abe a little bit about some of the reasons. It's a little interesting to see that we have less public research, even though we have all this published data about how you can hack your own car, basically. And I started wondering why and what's the issue there. And I think, not to pontificate too much, but I think it's interesting that there's some private research going on, and the private research is done with the OEMs, and they're finding bugs and they're reporting it, but they're interested in kind of that commercial deal. And the OEMs are very interested in keeping this information private from the sense of it can potentially be a safety issue, so I understand that. So we have to kind of consider that there is research going on, it just might not be publicly reported, and I'll talk about why that's a little bit of an issue from the sense of a researcher perspective and learning from our mistakes. Talk about kind of the industry and policy actions a little bit. What I really like is in September of 2016, the 2017 model of the Cadillac CTS was the first V2V capable vehicle on the market. So before even the mandate has come out, it is the first vehicle that has a vehicle-to-vehicle communication radio installed. Around October, that's when the DMCA exemption came out, so now it is legal for you to break into your car, find stuff about it, and then report it if you want, which will go out of effect next year. October 2016 is the NHTSA proposed rulemaking, or excuse me, cybersecurity guidance. This guidance, when it came out, was pretty influential. Am The Cavalry did a couple comments on it. It talked about a lot of the different kind of recommendations that automakers should have when they're building and deploying a new connected vehicle system. The guidance leaned heavily on the SAE guidance that came out before that. It was worked amongst a lot of partners, but it was a big win from NHTSA's perspective and actually getting some guidance out there about what you should do with your car. It's still proposed though. In December, this is when the V2V notice of proposed rulemaking came out. So V2V is still not required. And for those that don't know, V2V is the vehicles each communicate to each other. There's a whole set of standards. I think it's 802.1p, I believe. I don't quite recall it. But basically, each car will talk using kind of a short-range radio. But at the same time, it keeps privacy from the driver, but still can communicate at a very quick fashion, how fast it's going, where it's going, that sort of thing. It also communicates to infrastructure as well. And this is not just US. In the EU, they're also considering similar legislation. So this is a proposed rulemaking saying, if it gets approved, it would essentially require these radios to be installed on every single vehicle. In June, just recently, we had the first, well, not the first, but a more recent federal self-driving car legislation that introduced in the House of Representatives. So in particular, this is actually trying to show from a federal level, they want to be able to legislate the requirements for self-driving vehicles over the entire country, rather than having the patchwork of states where in some states it's okay to test it, in some states it's not. From the European perspective, we have the European Commission strategy on CITS, which is the Cooperative Intelligent Transportation Systems. Very similar to kind of the NHTSA guidance, but it basically focuses on not just V2V, but also the entire kind of connected car ecosystem. And they had a very comprehensive report that focused on what requirements that they're looking to see, not just from a cybersecurity perspective, but also just from a standards and connected vehicles perspective. In September, Volkswagen started their first automotive security company as a wholly owned subsidiary. So we're seeing kind of some trends, we're seeing movement. Not as quick as we've seen in the past, but a definite movement towards improving security in the US and the EU. Just overall trending though, if you think about it, excuse me, the policymakers and regulators in the US are a little hesitant to move forward on regulating just from the sense of they don't want to cause problems by regulating too quickly. And secondly, the EU has been studying vehicle security for years, since 2010, I believe, with the Evita report the Evita project that came out. And they're also moving, but a little bit more aggressive than the US, and they actually have very defined standards about what they're looking to see from a cybersecurity perspective. So kind of two different policy trends that are happening so far. So I kind of talked about the history of where we were in the last year, where we moved to. We're still, I think, in a similar state. We've improved a couple things, a couple of rulemakings came out. We haven't seen a lot of security research that I think has moved the bar too far. And so that's why I want to say, how can you guys get involved? How can you get involved in playing with vehicles, doing some car hacking at home, and doing some cool stuff. So first off, I just want to have a little word of warning. Cars are very expensive, as you all know. Not really ideal to test on your own vehicle, just from the sense of you do something and you might break your car. So Chris and Charlie, we know, broke their car many times, took it to the dealership, trying to get it fixed a lot. Usually not a good idea. So if you don't have a car, or you don't want to test on your own car, what can you actually do? So there's a lot of really awesome open source projects. From a hardware perspective, there's 3 really cool ones, actually more than this, but these are the kind of the ones that I'm most familiar with. Machina is a Kickstarter project where it's about $80 or $100 or so. You get the picture on the right there. It allows you to connect to OBD2, and it gives you access to a ton of different buses there. It's really cool. The Cantac project, very similar, a little bit older, but it's completely open source. You can build it yourself if you don't actually want to buy anything. All the source code, all the schematics are located on the website. Pretty neat. CamBadger, this is a little, I think it's around the same time as Cantac. It's a pretty robust project. Same thing, fully hardware open source. Download the source code. It allows you to access the OBD2 port. Allows you to do a lot of different kind of decoding of the different protocols, and at the same time allows you to kind of do a little bit more interesting kind of pen testing type stuff, like having multiple devices chained together to a server to try and test different buses on the car. Again, fully free, open source, if you want to check it out. From a software perspective, there's a lot of other cool stuff we have too. So I was going to list a bunch of open source projects and keep them here. But in particular, Jared the Coder has a really awesome repository of open source tools. Highly recommend you just check it out. It just pretty much lists most of the ones that I'm familiar with. Secondly, open garages. So this is Craig Smith's child, I guess. But basically, it's an open community where you just join. You join a local garage. You have access to resources. You have access to expertise, and share information and just talk about car hacking. All right, so you know where to go, you know where to get the tools, you know where to start. So what do? Well, you test what you know. So a lot of people, would say, well, I don't know CAN bus, I don't know GMLAN. How do I get involved in testing this? I'm not a mechanic. Well, you don't have to be a mechanic. If you look on the right there, this is the Mirrorlink architecture, which I talked about was broken at Woot last year. That doesn't look like CAN. That's all pretty commodity protocols that we're all familiar with. If you have AppSec experience, you can get involved with this very easily. But even if you don't, or you might have that and mastered that and have already done some of the work, start learning what you don't know. So CAN bus is the easiest way to start, and anyone who has a Linux box can literally get CAN on their Linux box in a few minutes. And finally, what's a really good resource, and it seems weird, is the car modding forums. So all the guys who've been doing car modding for years and years and years have figured this out. They understand how to reverse engineer the protocols. They've done the sharing. They've found the weird tricks that work in this model of a Pontiac Firebird versus that model. Not picking on Pontiac, just saying.
It doesn't exist anymore.
That's true. Good point. And in particular, and really Craig did not pay me to put this up here, but this should be your Bible. If you're interested in doing car hacking, just have it right here. So now you found something, you found a bug, you found a vul, you found something cool. Let's share it with everybody. As part of the Cavalry, we like to talk about sharing and the power of kind of people getting together and solving problems. When you share it, it moves the whole community forward, whether it's providing a talk, writing a blog, sharing just the research with individuals at a con, or at the Open Garages community itself. And like I said, I'm a vulnerability nerd, so disclosure is super important. We talk about safety critical systems. Vehicles are a safety critical system. So if you think there's a safety risk, it's pretty much going to be a big deal. You need to reach out, you need to report it, mainly because if you don't, you release it, potentially if it gets exploited, it can cause harm, and that's what we want to avoid. So cert.org, if you're having issues with the OEM, they'll take your vulnerability and coordinate it for you. AutoISAC will do it. Supposedly, they claim that they'll get you in touch with the right person, although they do not do vulnerability triage, is what they tell me. And then HackerOne and other sites also have, for example, GM's vulnerability disclosure policy is held on HackerOne. All right, so you disclose some bugs. You think you've gotten pretty familiar with car security. You're ready to kind of help out. Try to work on the solution. If you're interested, try to work on the solution. Maybe you care enough that you want to start working for an OEM, whether it's these guys or one of the other major OEMs, or even tier 1 suppliers. So they don't give a lot of love, but a lot of the vehicles themselves are just made up of a bunch of parts that are built by a lot of other people. A lot of them don't have security knowledge. So the big bureaucracies, they might not be the most fun to work at, except for GM, of course, right? But in particular, it's good to work with the solutions if you can. And finally, just kind of contribute and get started with an open source project if you're interested. So I gave you guys kind of a background into kind of where car security has been the last year or so, where policy's kind of sitting. But now I want to kind of shift gears a little bit and start talking with Abe here. He's going to kind of talk about his challenges he's seeing from his perspective, working on kind of a new vehicle architecture. And he's also going to kind of talk about some of the challenges he sees in the industry in general. So I'll invite Abe up here to talk, and then we'll move on with the rest of the talk. Just give me 1 second to switch slides.
So I want to start by saying thanks for you guys for staying so late. It's been a long day, but I kind of stayed out a little bit too late yesterday, so excuse me if I start to stutter. I tend to when I get too tired. But so my name's Abe Chen. I'm going to try to cover quite a bit of areas in about 15 minutes, so we have time for you to, or for a fireside chat, and also provide time for you to ask us questions. Okay. So let's start. Who am I? I work in Silicon Valley. I work in a place called San Jose for a company called NEO. Previously, I worked at a company called Apple, built the new product security team from scratch. Also was the first principal security engineer at Tesla Motors, and also built that team as well. So I hired the big works, the Kristen Pagets, the Javier Vasquez, and so forth. Okay. And so currently I'm at NEO, and a little bit about NEO, shameless plug. We are hiring, so if you have any, if you're interested, come and talk to me after the meeting or the talk. So currently NEO has our only car on the market right now, or semi on the market, is the EP9. It's a supercar. It's set the fastest, set the record for the Nürburgring for the fastest electric vehicle, as well as the fastest autonomous vehicle car around the Circuit of the Americas. So for a company that's only 3 years old, that's for us, we're very proud of that. I head product security there. The difference between NEO and previous companies I've worked at is that I have this belief that security should be building security. And I'll talk a little bit about this philosophy later on. And so what we do is we build security hardware or security-related hardware that goes in the cars. We write the security stacks that go on top of our platforms. And we build security components that manage the overall vehicles, let it be in the cloud or in-car. So that's very different from other perspectives from some of the other companies I worked at in the past, where security functioned more as a risk assessment apparatus or a consulting arm of the company. Okay. Let's see, so currently what I'm doing is I'm working on some really cool stuff for our target. Our goal is to have a level 4 autonomous vehicle in the US market by 2020. And so much of my team is working on that, as well as we're working on a China market vehicle that's to be released sometime next year. Okay. And we are hiring. Okay.
Level 4 in China next year?
No, level 2 in China. Yeah, level 4 for 2020. Yeah, level 4, we're still pretty far away from level 4. A lot of the technology pieces are there, but there's a lot of work to be done. So since you bring that up, one of the things that the big challenges from a security perspective is that, when I look at it, we're not ready for, connected cars are not very secure. So imagine a connected autonomous vehicle. What can potentially go wrong, right? So there's a ton of work in the security field that needs to be done before we're ready for level 4, regardless of whether the cars can actually perform at level 4. So it's been 4 years since the first auto manufacturers started to reach out to the security research community. It's been, let's say, about 3 years since the Cavalry published the first the 5-star automotive cybersecurity safety program. And it's been 2 years since Valsec and Miller demoed their Jeep hack, right? Also, we know that as a result of all that effort and those work by all those companies and people, individual people and security researchers, we now have some level of awareness, and that has sprouted lots of security conferences, right? So there's a lot of security conferences. You can basically go to one security conference every month at this point. But unfortunately, improvements are still very slow. And I know this because I work with different suppliers and engineers and teams and stuff, and I'm still finding some of the same challenges. And what I hope to do is to kind of talk a little bit and share a little bit about what my team and I as well are seeing in the industry, and why we believe that where the issues are and how we think what needs to change before we can get to the point where we can build much more secure vehicles, more robust security systems. Okay. So to start off, I have this concept that I always bring up with my team about the catch-22s of vehicle security. So how it kind of works is the supplier sells capabilities to the OEM. And of course, it's not always the same for every OEM, but this is very generic. So just keep it generic, right? OEM decides whether it's cost effective. Okay, it's very expensive to build cars, very expensive. Okay. And then OEM knows only what, sometimes, most of the time, but that's starting to change, only knows what the supplier shows them. So supplier says, hey, I have this new feature set, it's really cool. Okay. OEM works with tier 1 suppliers, and unfortunately they're slow to buy from smaller security firms that provide very specific, potentially robust security features. Okay. And so there's this cycle that goes around. And so that's part one. Part two is the industry tends to follow. Okay. Because it's expensive to build cars, building cars is very risky. There are introducing new capabilities can cause all sorts of potential safety issues. So oftentimes what will happen is that a vehicle OEM will watch to see another vehicle OEM take that chance first before they jump in the boat. So for example, Tesla started the bug bounty program and then embraced researchers, and then over time, other OEMs started to come on board and have their own bug bounty responsible reporting programs. So this is one example. Okay. I'm also seeing this trend where there's a lot of talk about adopting IT security, right? Or this term that's been coined as data center in a car. Okay. And my take on that is that that's a really bad idea. Okay, because IT gets hacked every day. Okay, there's the model that we use, I believe, in IT security or information security is wrong, and we could talk a little bit offline because maybe I'll do a talk in the future about why I think that is. I've been in the doing IT security for close to 20 years, so before I transitioned over to vehicle security, and when I first started working in vehicle security, I also had this belief that I could just take my knowledge from IT and apply it to a car. Embedded systems are very different from computers. They're not the same. Embedded systems, networks are very different from computing systems. But some of the basic concepts cross over, but protecting these systems, it's a totally different beast. Okay. Secure programs tend to be reactive. It's kind of like I, the security professional, will go to management and I say, you need to do this, right? And then they'll say, well, there's no evidence of this being a problem. My friend's company doesn't have this issue. Why do I need to do this? So we go through this process of where an incident occurs, and then it's a I told you so, this type scenario, which we of course hate having to be in. And then we get some money or we get some headcount, and then just enough to get us to the next incident. Next incident happens, you see this all the time. We get more money, we get more headcount, and then this cycle just keeps going. Or we have technologies that are just, like new technologies pop up, we buy it, we see new technologies, and then suddenly you have 50 different kind of technologies there to protect your network and cost you $1 billion to even have a sense of security, but yet at the same time you're still getting hacked. So this is reactive program, right? And the reality is what happens is that real incidents often equal half efforts, and lots of incidents really don't result in the finished, a secure solution. It only gets us a quarter of the way there. Okay. Legacy costs. So legacy is a huge issue because, especially in auto industry, you have it's expensive to build cars. It's expensive to re-architect. So unfortunately, and I'll explain this a little bit, what you'll find in a situation, not just in the auto industry, but a lot of industries for IT, even IT related to IT security, where people don't want to spend the time to fix it, no matter how horrible are the consequences. And this is my personal feeling, is that for me, I've been fighting a battle for the last 20 years, and maybe the public is just starting to realize many of us in this room have been fighting battles for longer than I have. And the reality is we're losing. And when you're talking about an autonomous vehicle, right, an autonomous connected vehicle, there's no room for compromise. And so, yes, so that's part of it. Okay. The reality, also another point, is that cars are actually made to be hacked. Okay. There are laws out there that ensure third parties and owners of vehicles have the right to modify certain components of the cars. When those laws are written, and this is a point that was brought up by Kevin earlier, when those laws were written, security wasn't even really, nobody thought about security. So we have this challenge where we need to build secure cars that can be modified by owners, okay? And so that's one of the problems. And so what we're seeing is this, and this is a little off topic from that bullet point, but so this is why, you could take a component out of the car, replace it with a Raspberry Pi, suddenly the car's been hacked, right? Well, you had physical access to the car. The car was designed so that some third-party mechanic or you yourself can repair, right? So it's not designed to prevent you from taking that component out and replacing it with something else. Okay. And so that's one of the issues that we're seeing. Okay. And then another point is, last point that on this as to what's causing these issues, is that there's just arrogance or unwillingness to share. I think we're at the point where I believe that OEMs and suppliers should be sharing information about issues that they're seeing, sharing information on how things should be fixed, right? Security is not something that, of course, it could be potentially a competitive advantage, but when you're looking at or talking about safety-related systems, there's something that should be at a higher level, right? So this whole attitude about first to market wins, I don't think should apply here. That's another one of my personal opinions, right? Okay. So what needs to change? So very important, we need you, okay? And this is a big thing, big issue right now that we have, is that we're starting to get the trend where we have more and more security researchers looking at the problem, finding problems, but we don't have anyone to fix the problems. We don't have engineers, we don't have developers that are trained in security or who understand security fixing these issues. Okay. So security research is very important, but at the end of the day, someone needs to fix that problem, and we just don't have enough bodies to fix that issue. And this, Kevin, I was talking about this, where we're struggling to find the right people to do the work. I literally comb the world. I have a guy from Spain, I have a guy from Germany, I have a guy from Turkey, I have a guy from China. It's just literally I have to comb the world to find these guys. Okay, so if I'm hiring. So again, shameless plug. So if you're interested, come talk to me. Okay. And then there's this other concept, which I brought up earlier on the session, is that let security build security. Okay, this is important. Those that don't care about security are building future tech without it. And this has been happening for forever. Okay. And if you have an engineer building a function and someone in the room says, hey, maybe we should think about security, the engineer says, okay, I'll go figure it out. And oftentimes the result might not be secure. Or if, I'm sure many of you, if you're a developer or engineer in the room, would know that if the project schedule, you're falling behind, security is oftentimes the first thing that's tossed out. So that's an issue. That's why I say security should be building security. And that's the approach that I would not have signed on to NEO unless that was something that was guaranteed. That security professionals build security features or security capabilities. Engineers, learn, or engineers that aren't security engineers learn, but security engineers need to build the security features. Okay. Also, let's say if you want to get involved in security, but you're not in a role that's security focused, this is also a great opportunity for you because you can be the voice in the room. We don't have enough voices in the room. When those engineers who don't want to, or developers, oftentimes they don't want to include security in their meetings because security always has something to say that will slow the project down, right? So, but if you're an engineer or a developer and you're in the room, be the voice, speak up. And then what I've seen with some of the folks of how they got into security is that when they spoke up, they were the one who got the work, right? And so they went out and learned security from other security professionals and became security professionals themselves. So that will help this in the cycle, for us to get more security professionals. Okay. OEMs, their suppliers are always hiring firmware and hardware engineers. So, again, embed ourselves, lead security efforts. Okay. And then the third point that Craig Smith always reminds me of is that cars needs to be serviceable by third parties and yet smart enough to defend themselves. So autonomous security, this is the term of autonomous security, needs to be compatible with third-party services. So let's say we start building security that's automated, but at the end of the day, you still need to be compatible with the third-party service models. And I think that's it for me. And how are we doing on time? Okay, cool.
We're good now. No interference. Sorry about that. Making sure you're all awake. Thank you, Abe. And I really want to bring back to the point about the right to repair. I think that's extremely important. I think it's Massachusetts in particular that has the right to repair law. But beyond that, the reason why you have so many things in your car is because of different legislation. So the EPA guidance is why you have an OBD2 port stuck on the lower left side or right side of the driver side. So these things are important and they're there for a reason. But at the same time, they weren't meant ever for a vehicle where no longer is it constrained to just physical access that can cause an effect to the vehicle itself. It's beyond that. It's anything connected to it now. And that's the challenge that the industry faces as a whole. And so as the next part of our show, we're going to talk with Kevin, and we're going to do a couple Q&A. With him, I have some questions that we're going to start out with, and then we'll open it to questions, and it won't be just to Kevin, too. It'll also be to Abe. So we'll kind of hear Kevin's perspective in working for one of the largest automakers in the world, and dealing with a myriad of problems from a massive legacy problem to trying to kind of convince an engineering organization to do things differently in a better way. So I'd like to introduce Kevin Tierney from General Motors.
So good evening, I'm Kevin Tierney. Thanks for having me. It's my first time at B-Sides in Las Vegas, so it's great to be here. Can you hear me okay?
Speak up just a little bit.
Okay, maybe I'll move it up. Is that better? Yeah. Okay. So I want to talk a little bit about kind of my view on product security, and I think I agree with pretty much everything you guys just said. It's a huge space, and General Motors, I have the privilege of working for a company that takes cybersecurity of its products very seriously. And I think that's one of the main reasons I'm sitting here today, is because we have leadership that understands that security is an important aspect of product development. And because of that, we have a team, we have resources, we have the headcount, arguably before it becomes an incident response exercise on a product. And so because of that leadership support, we have a global team of almost 80 people working on product security. So within GM, we have an information security organization that's focused primarily on the IT portions of the system. And then we have a product security organization that I'm a part of with a chief product cybersecurity officer that's charged with just the security of the end-to-end products. So the vehicles, the mobile apps that interface to the vehicles, as well as the telecommunication and systems like OnStar that I'm sure you're familiar with. So it's been a priority at GM for quite a number of years. I mean, you referenced some of the research back to 2010. We were actually heavily involved in that at that time, and we've continued to grow our organization since then, realizing that the threats and the risk of connected vehicles and autonomous vehicles are only going to continue to grow. And so we take a defense in depth strategy and approach into our vehicles, and while this is a journey, there's not an end state here. It's a continual evolution that we're taking with our vehicles. There's a lot of momentum that we see within GM and the industry. You referenced the auto ISAC and what they're doing. And I think it's great because finally the OEMs are getting together at the table. The suppliers are there. Information is being exchanged. I'd say it's still early days. There's not as much vulnerability information being shared as we want, but we're getting there. And GM's one of the leaders that we always publish information there with attribution, and people call us and ask questions, and we're always trying to lead that interaction. So within GM, and maybe just to wrap up a little bit on what my role is. So I report to our Chief Product Cybersecurity Officer, Jeff Massimilla. Some of you guys are probably familiar with that name. I'm responsible for the on-vehicle security. So I lead our on-vehicle security architecture team. So those are the guys trying to figure out how to secure CAN, where do we go with on-vehicle networks, what's the right way to secure diagnostics in the face of right to repair, how do you program modules, whether it's through service tools or over the air, and how do you do that securely, and what's the balance between that, vulnerability management through an OTA mechanism versus having that ability, which is a security challenge in and of itself. And so a whole myriad of things are in that team. I also run our own internal red team. So we have, I think, one of the industry first. I know Tesla has a team, a red team, but we have about a dozen guys that their full-time job is doing red teaming on our systems and really focusing on the embedded systems in the vehicle and the mobile apps and things of that nature. I also have a governance and risk management function. So while we want to design in security from the start, of course, we're looking at the architectures up front and making sure things have the appropriate security posture from the start. There is a risk management function, especially when you have a company as big as GM. You can't do everything all the time, so you have to really depend on some of those mechanisms to help you sort through what the priorities are as you move through the process. And then incident response. So while I think we're starting to work ahead of the problem, we know that something will happen. Minor things do happen, and so we want to be ready and prepared for those events. And so we also have our own incident response capability that we partner with IT security as well, because many things kind of bridge between the two domains. So that's a little bit about my background and where I'm coming from.
That's great. And you mentioned the auto ISAC, and I know Faye Francie, he used to be at the aviation ISAC, now is the general director there and has done great work. So definitely, it's a step in the right direction. So Kevin, I also want to ask you kind of a couple questions, and then we'll move to audience. With all the major OEMs and tech companies even moving towards fully autonomous vehicles, what do you see is the biggest challenge to make sure that security isn't left behind in this race to get that first vehicle out there? Because really what keeps me up at night is those dates I showed you. We're moving very, very quickly to that 2020 date, that 2025 date. And it's going to be too late if we have to wait until those vehicles are already on the road and people are inside of them. We want to make sure it's tested way beforehand, and we want to make sure it's done in such a way that I don't think stifles the industry, because I think we have to consider the option if we don't have autonomous cars. And the reason why autonomous cars are so interesting from a regulatory perspective is that the most common cause of death in a vehicle is by human error. So you remove human error, you save lives. So we have to balance that with the cybersecurity component and the potential to do harm there. There's a potential in doing nothing that we cause more harm. So it's a difficult balance. And I kind of want to just ask you, what's the challenges you see in getting to that level?
Well, I think the positive aspect is cybersecurity is now a real thing within the industry. And so the fact that we're developing autonomous vehicles and it's top of mind for I think most of the automakers, I think is a good thing. Within GM, we have our own dedicated AV security team. They report up through product cybersecurity, but they're devoted 100% to AV security because some things are going to be different. The architectures are going to be slightly different than a traditional connected vehicle. And so there's new technologies there's new risks, there's kind of a new paradigm because the autonomous vehicle starts to look less like a car and more like other things like airplanes and other systems where you have to have high uptime, high reliability, fail operational states, which are a little different than a traditional vehicle. So I think having a focus from the start, having a voice at the table as you're developing these systems, I think is critical. And I know we're taking that approach, and I think others are as well. You talk about regulation, and there is obviously some bills going through that actually have cybersecurity language in them, which I think is a step in the right direction in terms of trying to get everyone to an equal playing field. Regulation, I don't think ever solves security, but at least maybe in this case gets everyone up to some basic threshold. But to your point earlier, launching an AV program without security is I think crazy, right? And in our perspective it has to be there just like safety. You have to prove that the systems are safe. You have to prove that they're secure. You have to prove that they're reliable. All these things that are required to prove that you have a commercial product has to be there before you launch. And security is one of those checkoffs at GM that is absolutely required, and again has the support of our senior leadership.
And you mentioned vulnerabilities, and I want to kind of ask you a difficult question. So prepare yourself a little bit. So last May, National Highway Transit Safety Administration released an interesting proposed rulemaking, and this was basically the fundamental question was when is a vulnerability considered to be a safety issue? And then they looked at it from the sense of that entire ecosystem of connected things to the vehicle, and basically implied that if your app that caused a vehicle to engine turn on or turn off happened to be hacked in such a way that could cause a safety issue, you have to recall that application the same way that you would a faulty airbag. And so what I want to ask you is what do you think about that? When do you consider a vulnerability to be a safety issue? Is it a safety issue? And how do you determine that threshold? Yeah. I'll wait for your best answer. That's a tough question.
Yeah, no, it's a tough question. It's the right question, and it's a hard question because I'd still say the industry is trying to figure out that right model. I think absolutely some vulnerabilities are safety issues. Absolutely. I don't think all are. There's a lot of vulnerabilities out there, and I'll use an example. So you guys have cars, parts break, things fail. Not all of those are safety issues, right? And so whatever you want to call those, warranty issues or quality issues, I think it's similar to the ocean of vulnerabilities that could exist in your vehicle at different parts of the system. Now, there's a lot of work that goes in between the OEM and NHTSA to determine which of those failures actually are safety defects that are recallable. And it's only a very small percentage of failures that actually lead to a recall. And so I think it's kind of a similar process that we have to work through, is to understand the vulnerability, what it can impact, and through a very detailed analysis, if we prove that yes, this has some impact on the safety systems, then yeah, absolutely, it follows the safety process. Mm-hmm. And so that's what we've instituted at GM. So we're very aligned with the safety process. We actually link into the safety process if we hit a certain threshold when we are analyzing a vulnerability, and we let safety run it, and they're the ones that primarily communicate with NHTSA and things of that nature if there's some sort of issue. And so what we do is, you look at a vulnerability, and it could be just a minor vulnerability in a piece of software that's way upstream in a system, and that by itself doesn't tell you if it's really a safety defect. You really have to do very complicated, I'd call it system threat modeling, looking at how does that vulnerability exist in the software? Can it kind of get outside that piece of software or the other software that's around it? What's the context of that system? Can it get on a network? If you get on a network, are there firewalls between that and other safety critical systems, on and on and on. There's usually multiple steps that have to occur for one vulnerability to actually execute something in a system. And so we have to take all that into account, and we've built a lot of threat modeling and system risk assessments around that sort of methodology. And then once we get to an end state and we understand, hey, this is what could occur, then we run it through the safety process to say, hey, yeah, this is something, or no, this isn't. So sounds good. It's hard. That's not easy. It takes a lot of hours, a lot of domain knowledge. You have to understand how your system works. You have to understand how that vulnerability can interact in that system. And so it's a continual process, and we have to figure out how that's going to work at large in the whole industry. But that's the approach that we're taking. So yeah, absolutely. I think some will, but I don't know that all. And we have to figure that out over time as more and more security controls are introduced. One vulnerability doesn't necessarily mean a recall in every case.
Yeah, that's a good answer and interesting. Yeah, from a CVSS perspective, I scored many vulnerabilities, and you look at it from that perspective, you're looking at one system, one tiny vulnerability. It's a lot different when it's a whole vehicle like that, and you have to consider the system itself. So that's interesting. We have 5 minutes left, so I want to make sure we have time for questions here. So please grab a microphone and let's ask some questions. I think there's people walking around. I see one up in the front, one in the middle here.
This year I bought a 2017 GM Long Range EV, but with the 1016 DMCA exemption on vehicle reverse engineering, GM still made me sign I won't reverse engineer the firmware of my car.
I think that was a purchase contract.
Yeah.
I mean, yeah, it's not necessarily our purchase contract. So, and I don't want to get into that too much, except what I will say is I think it's been obvious that GM values the work of security researchers. We do have a coordinated disclosure program on HackerOne where you can go look at the language there and see it's pretty easy to abide by, I think, in my mind. So, yeah, the legal world out there around this stuff is complicated, but I'm an engineer. I'm not a lawyer. Understood.
Question up here.
Kevin, you mentioned this when you talked about securing vehicle networks and also the threat modeling. Are there plans to replace or augment CAN bus with something authenticated to protect against malicious actors on the CAN bus, or is the focus on keeping the threats out, away from the car?
Yeah, I think it's both. And so not to get into too much detail about our future plans, some of this is public record. There are plans to augment CAN with authentication mechanisms. The big challenge there is it's a very low bandwidth type of network, so you can't do maybe the full security that you may want to do, otherwise you can't send any data over it anymore. So what you'll see is an evolution of authentication mechanisms, and then likely some higher speed bandwidth networks in future architectures that we're working on. There's something called CAN-FD, which is I think about 2 megabit, and then there's Ethernet, obviously, that gets you there. Sometimes I say that going to Ethernet may actually create more problems in the end. So it's hard to say exactly what we're going to land with, but we're going to have higher bandwidth networks. There's going to be authentication, but we're also going to try to block people out as well. It's really, like I said at the beginning, a defense in depth strategy. I don't want anyone in a vehicle network. I kind of assume that if you're there, I've already lost. But if you're there, then I want to have something else there to make it harder for you to masquerade as a device and be able to send a safety critical message. Thank you.
I think we had a question in the back there.
Yeah, hi. You said previously that you have to kind of prove that your product is secure before you ship that. And in traditional IT, it's not necessarily a hard problem, but it's something that takes much effort if you want to do that. So how do you do that with your cars?
A great question. It is a lot of work. I referenced we have about 80 people working on this, so there's a lot of systems that we release every year, a lot of software that we release. And basically what we've instituted is, not unlike in an IT environment, an SDLC process that mirrors our vehicle development process. So for every component that sits in the vehicle that does something that could be of concern from a cyber perspective, generally all the components that have software is what we look at. And if you think about it, a vehicle has like 30,000 parts. It's only about 100 parts or so. So of those, we run through a very dedicated process, doing pen testing, scanning, software, analysis, code reviews, etc. And all that gets summarized, in a report before we go to production. So I know I'm running out of time, but at a high level, that's what we do for our products every cycle.
All right, I think we're pretty close on time. So I want to thank everybody for stopping by this late. We'll be here a little bit afterwards, just if you want to ask us a couple questions. And I'm not sure if Abe and Kevin are going to be here later this week, but feel free to just come by and just talk to us. But thanks for stopping by, and please come hack cars. It's cool.